Greetings, Alliance Chemistry team, Commander King here, and we are taking a look at stoichiometry and how to solve for stoichiometric related problems. So all stoichiometry is figuring out, okay, if I want to produce how much of this stuff, well, what do I have to do? And in this case, we want to produce NH3. And this particular reaction we learned about is called the Haber process. It's used to create fertilizer, and it feeds millions and millions of people around the world. This was an incredible discovery that helped create fertilizer and hence increase production of crops. So a super, super important reaction in terms of historical perspective. All right. And so we want to create fertilizer to feed people on our exoplanets, on our planets out there, and our colonies. And so we want to produce this NH3. And for now, I just want to produce a packet of 50.0 grams of NH3. That's my goal. Okay, and my question is, hey, if I want to produce that, how much nitrogen am I going to need? How many grams of that? And how many grams of hydrogen am I going to need to put in to this so that I can get out 50 grams of this NH3? Okay, and you might look at this equation and think, okay, well, I just need one of the N2 and one of the H2 to create NH3, but, okay, I quickly realized, wait a second, that doesn't quite balance out. I've got 2 H's here, 3 H's here. So the first thing I want to do before I can really tell how much of each I need is to balance the reaction. So let's see, I've got 2 N's here. I only have 1 N here, so I'm going to put a 2 here, so I've got 2 N's. All right, but now I've got 6 H's. All right, I've got 2 H's here, so I need 3 of the H2 molecule, and now I'm balanced and ready to go. My equation is balanced, everything's happy, I'm ready to move to my next step. All right, now let me analyze what this equation is actually saying, and you might want to jot this down. So what this equation is saying is that if I have 1 molecule of N2 and I mix it with 3 molecules of H2, that's going to give me 2 molecules of NH3. And a bigger way to look at it, because when we mix things, we're not dealing with just 1 molecule and 1 molecule, otherwise it would take forever to make it. You might think of it as if I mix 1 mole of N2 with 3 moles of H2, then I'm going to make 2 moles of NH3. So if I have 1 of these and 3 of these, I get 2 of these. Okay, but unfortunately, I don't know how many of the NH3 I have. I only know I have 50 grams, right? But luckily, we know a conversion to get from grams to moles, and that's going to be the key, because once I get to moles, I can figure out how many moles of H2 I have and how many moles of N2 I have. So if you remember, we kind of, to help us out, set up this awesome box here. So I'm going to do that. All right, and I'm trying to recall that in the first row I put the amount, and that's usually grams, but it could be something like liters, and down here was always the moles, or how many, right? How many N2 molecules or how many H2 molecules am I using up? So my first step is going to be to convert to moles of NH3. Then once I'm at the moles of NH3, I can take the next step and convert to moles of H2 as well as moles of N2. We're going to take a look at that. And then the final step is to then convert from the moles of N2, because I'm like, hey, you need 6 moles of N2. Well, I can't literally count out 6 moles. I need to measure that. In order to measure that, I'm going to actually measure it through its mass, and that's going to be the final conversion. So really a 3-step process here. So let's start with the first process. I know I have 50.0 grams of NH3. From my plan here, it looks like I need to go to the moles of NH3 so I can figure out how many I have. All right, so I'm going from grams to moles. And this isn't too hard. I just need to think about what's my conversion. So remember, this row is the conversion. Well, my conversion is the molar mass. Where do I get the molar mass from? The periodic table. So if I look at my periodic table and I look at N, I see that N is 14.01 grams per mole. And oxygen, sorry, I don't care about oxygen, I care about hydrogen. Hydrogen has 1.01 grams per mole, but I have 3 of those, so I'm going to add those up. But before I do, let me set up my units. I know I want to cancel my grams of NH3. I'm going to put that at the bottom. And I know I want to get to moles of NH3, so I'm going to put that at the top. Okay, all right, so I take my 14.01 plus 3 times 1.01. That's going to give me 17.04 grams of NH3 per 1 mole. So I'm going to take 50.0 divided by 17.04 times 1, which is the same thing. That gives me 2.93 moles of NH3. Great. So now I know I have 2.93 moles of NH3. And I'm just going to label this step 1. Okay. And that's good because I know to make 2 moles of NH3, I need 3 moles of H2. So to make 2.93 moles, or just slightly more than that, I know I'm probably going to need more than 3 moles of H2 because I needed 3 to make 2, 3 of the H2 to make 2 of the NH3. So I'm probably going to need, I don't know, maybe 4 to 5 of the H2 to make 2.93. But anyway, I don't really need to think about it too much. I'm just going to do the calculation from here to here. So let's see where I'm trying to go. I know I have my moles of NH3, and I know that I just calculated I have 2.93 moles of NH3. And I'm trying to get to moles of H2. So I'm trying to get to moles of H2. So let's look at my units first. In order to get there, I need to cancel out my moles of NH3. And I'm going to my moles of H2. Okay, now, let's think about it. Well, do I know my relationship between my moles of NH3 and moles of H2? Oh, right, I do, right? Because I look at my reaction here, and I've got 2 moles of NH3, and I need 3 moles of H2. So look at that. I got my ratio between these two, and I can use that right here for my conversion. So it looks like for every 3 moles of H2, I produce 2 moles of NH3. This is really all this is saying. It's saying that these are the same thing. When I have 3 moles of H2, I make 2 moles of NH3. So I'm going to do that, 2.93 times 3 divided by 2. And that gives me 4.40, about 4.40 moles of H2. Okay, and I can do a similar thing for N2. I can now really start from anywhere. I can either start with the 2.93 or the 4.40, but I'm just going to start with the 2.93 because that's where I started before. But this time, instead of going to moles of H2, I want to know the moles of N2. Okay, this time, I still put the moles of NH3 at the bottom. I'm going to the moles of N2. So this time, I'm thinking, all right, well, how many moles of N2 do I need to get to? 1, right? I have no coefficient here. It's just kind of like 1. And here I've got 2 moles. So instead of 3 over 2, because that was the ratio between the H2 and NH3, I have 1 over 2, the ratio between the N2 and the NH3. So I take 2.93 times 1 divided by 2, which gives me about 1.47 moles of N2. And if you notice here that this number, 2.93, is double this number, 1.47, because we need this in a 1-to-2 ratio. So you can just quickly check, do these numbers, are they in the same ratio as up here? And this one is about 3 times as much as that. So I'm looking at that, I'm like, hey, okay, that seems about right. Okay. All right, now I've got one final step to go to the grams of N2, because remember, my original goal was to figure out how many grams of N2 and how many grams of H2. All right, well, how many grams of N2 will I need? Well, I'm starting out with 1.47 moles of N2. I'm trying to convert up. I'm thinking, all right, well, what's my conversion from moles to grams? Let me just write this out first. I'm trying to get to the grams of N2 now. How do I convert up? Well, I know I need to cancel my moles of N2. I need to get to my grams of N2. What's the conversion for that, from grams to moles? Oh, right, the periodic table. So I'm going to look at my periodic table. I know N is 14. I have 2 of them, times 2, 28.02 grams per mole. Over here, I could have written 17.01 grams per mole. Or was it 04? Sorry, 04. That's my conversion. I see that, and I'm going to use that, 28.02 grams per 1 mole. I take 1.47. In 1 mole, there are 28.03, so that means in 1.47 grams, there are 41.20 grams of N2, though I don't need this if I'm using sig figs. 41.2 grams. Okay. Now, I could do the same thing and do another step to calculate this grams, but one important thing I need to remember is the conservation of mass. The masses of your reactants have to add up to your mass of the product. And so I know that the N2 plus the H2 have to add up to 50. Well, I already got 41.2, so if I take 50 minus 41.2, that's 8.8 grams. And so I know H2 is 8.8 grams. If I did the conversion up here, I should get the same thing. All right. This is a lot to process, so you might want to rewind, go through a few steps again, make sure you understand each step, and then try to apply it to other reactions. Okay, hope these stoichiometric problems were helpful. This reaction alone is feeding plenty of people. And until next time, King out.